Miss Carter!
Que uva, Mara! What's up, Miss Carter? Today we're going to talk about the impulse momentum theory and the conservation of the law of conservation of momentum. What is impulse momentum theory? It's when the impulse of an object is equal to the momentum that it causes.
Yes.
What is the law of conservation of momentum? When the momentum remains the same for any closed system upon which there is no net external force.
Well,
Right now, we are going to explain a situation for impulse momentum theory. And the question says, a 0.144 kilograms baseball is pitched horizontally at 38.0 meters per second. After it is hit by the bat, it moves at the same speed but in the opposite direction. This question consists of 3 parts. The first one says, what was the change in the momentum of the ball? The second one, what was the impulse delivered by the bat? And the third one, if the bat and ball were in contact for 0.80 milliseconds, what was the average force that the bat exerted on the ball? Right now, we are going to solve the problem. At first, we list the knowns and unknowns. As the problem says, we have the mass of the ball, that is 0.144 kilograms. Then it is pitched horizontally at 38.0 meters per second. Then we move to part A. Part A says, what was the change in momentum of the ball? The formula that we are going to use is P1 equals mv1. And now we multiply 0.144 times 38, 0.144 times 38, and we get 5.472 kilograms times meters per second. That would be momentum 1. Then we need to find momentum 2 by P2 equals mv2, which would be 0.144 times negative 38, and it would be negative 38 since it is moving at the opposite direction. And we get negative 5.472 kilograms times meters per second. Then then we need to find the change in momentum. And the change in momentum formula is P2 minus P1, negative 5.472 minus 5.472, and the answer is negative 10.944 kilograms per meter per second for the first part. Then part 2 says, what was the impulse delivered by the ball? As we all know, the formula for impulse is F delta T equals change in momentum. So now that we have the change in momentum, which is 10.944 kilograms per meter per second, that would be the answer. Then, part 3 says, if the bat and ball were in contact for 0.8 meters per second, what was the average force that the bat exerted on the ball? As we know, the time is 8.0 times 10 to the negative 4 seconds. So we plug in F times 8.0 times 10 to the negative 4 equals 10.944, which is the change in momentum. Then we divide 8.0 times 10 to the negative 4 on both sides, cancel, and we get, for the average force, 1.4 times 10 to the negative 4. Right now, we are going to explain the situation of the law of conservation of momentum. And the problem says, 2 freight cars, each with a mass of 3.10 to the 5th kilograms, collide. One was initially moving at 2.2 meters per second. The other was at rest. They stick together. What is their final speed? Now, we are going to use the formula PA2 plus PB2 equals PA1 plus PB1, which goes like this. Now, we plug and shove. For mass A, we have 300,000 kilograms, and for first velocity, we have 2.2. We multiply that, and then we add 300,000 kilograms times 0, which equals to 600,000 times V2. Then, we multiply, and we get 600,000 plus 0 equals 600,000 V2. Now, we divide in each side 600,000 by 600, and we cancel. And for the velocity, we get 1.1 meters per second. Then, we are going to show this situation by little trips that were made. To Mundo Feliz. To the go-kart track.
Despacito. Ah, muy duro, pues muy duro. Va casi.
infierno ya. Seguí, hombre. Buena, Nutri.